The reaction what we are seeing is benzilic acid rearrangement. For this, the starting compound is diketone. You can see here carbonyl carbon. This is secondary carbonyl carbon. They are directly connected. These are the other groups. R group may be any alkyl, ethyl or any aromatic group. So these are R. The reaction starts with attack of nucleophilic hydroxyl group. In this reaction we have to use base. Say there is sodium hydroxide. So sodium hydroxide will produce OH minus. So this is OH minus. Oxygen bears negative charge, and this carbonyl carbon is electron deficient. This carbonyl carbon is also electron deficient because the pi bond is polar, and oxygen, because of electronegativity, can take the electrons, and therefore this carbon and this carbon experience electron deficiency. Now this hydroxyl group, that means oxygen, which is negatively charged, can nucleophilically attack on this carbon or on this carbon. Say this hydroxyl group is attacking on this electron deficient carbonyl carbon. So this OH minus is attacking on this carbonyl carbon. So it will form a bond with carbon, and simultaneously this bond, because it is polar, so it is breaking and both the electrons are taken by oxygen. So oxygen will have now negative charge. So understand what happened here. The carbonyl carbon is attacked by OH minus because electron is given by O minus to form this bond, so it is now neutral. Double bond was present here, pi bond is broken, electrons are shifted on oxygen. Now this is intermediate structure, and this is not stable because here it is oxygen bearing negative charge. So again this oxygen will share these electrons negative charge with carbon. Already the carbon is having 4 valency, so one bond is required to be broken. This bond is already formed, so we are not considering this bond breaking. We are considering this bond. Say this bond is breaking because now here these electrons are shared, so this bond will be broken. And if you see, this bond will be broken with electron. This R will break with electrons R, and this will connect to this electron deficient carbonyl carbon. Now this breaking and this connection happens simultaneously. Okay, so like this, now it is connecting to this carbonyl carbon with electron, and this pi bond is broken. Simultaneously electrons are shifted on this oxygen, so this oxygen now is electronegative. So what happened in this reaction? In this reaction, this negatively charged oxygen shared its electron, double bond is formed, and the alkyl group or R group from this carbon is broken, and with electron it is connected to this second carbon, 1,2 shift, and these traps took place simultaneously. So if you see actually what it is acid. Now this is, you see, this is acid is formed, OH. Okay, so this is COOH, acid is formed, and you see this is C, oxygen now here is bearing minus charge. This is migrated group from this carbon. Now this is negatively charged, unstable. This is carboxylic acid which can easily produce H plus, So they say this H plus is broken from this carboxylic acid. It will connect to this oxygen, which is negatively charged. Now, because electrons are used to form a bond with hydrogen, so there will be no negative charge. Okay, and this is because hydrogen is gone from here without electrons, so this oxygen bears negative charge. Now this is carboxylate anion. Alpha position there is hydroxyl group. This compound is then treated with any acid H plus. So that acid produces H plus, and this H plus will connect to this O minus. So we will get this acid as a final compound. This is alpha hydroxy acid. So in this reaction we are taking 1,2-diketone we are taking, and the reaction takes place. Strong base is attacking on carbon, there is migration of group, and finally we are getting carboxylic acid derivative, which is having at alpha carbon hydroxyl group, alpha hydroxy carboxylic acid. So this is known as benzilic acid rearrangement.